All right, so this is what we want to go ahead and do today. Last week, we did a lot of introductions as far as the IA. We talked a lot about that. Has anybody kind of nailed down, or they think what they're going to be doing as far as their topic? Some folks yes, some folks no. I've already had some folks come to me and kind of talk about their topic. But besides the test we talked about next Thursday the 30th, there's also something else to do that day. That topic outline. There you go. So kind of be thinking about not only your topic, maybe how you're going to be able to get your data, how you're going to collect it, whether it's yourself or if you're going to use a site that already has collected the data for you, what strategies mathematically you think you can use for that. And it doesn't have to wait until the 30th. If you want to go ahead and turn that in early, if you're ready, I'll go ahead and take it. If not, the 30th is when I'll be looking to collect those. Well, let's see what we got today. All right, so we're going to be looking at intros to statistics, classifying data, frequency tables and histograms, stem and leaf plots, box and whisker plots. So probably the one I'm not going to be spending a whole lot of time on is going to be the stem and leaf, because I've never seen one of those ever show up on the paper exams. And it's a good way to catalog your data. It's just not one of the better ways. It's just not typically used. Box and whisker are definitely going to be better. Frequency tables, histograms. All right, so let's see. Statistics. The science of getting facts from figures involves the collection, organization, and analysis of sets of observations called data. The data represents individual observations to which we can assign some numerical value or categorize in some way that identifies an attribute. The set from which the data is collected is known as the population. The population can be infinite or finite. However, the data collected will be a subset of this population. And we spoke to that as a group within a group. Okay. So let's see here. Such a subset is called a sample. Now remember, I believe it was on Friday, we talked about complete enumeration versus a partial, the census versus the sample. Okay. All right. So the process of gathering the data is known as sampling. So once we have our sample, we use the characteristics of the sample to draw conclusions about the population. This is known as making statistical inferences. Note that statistical inference is quite different from simply collecting data and then displaying or summarizing it as a diagram, which is known as descriptive statistics. Now, you could absolutely go ahead and use that in your IA, and in fact, I would encourage you to do that. A lot of times, visually, seeing the data can help you understand or see relationships much better than just a notation on paper. But here's the random sampling process. You start with your population, whatever your process was. Remember we talked about different ones the other day. A random sampling process, among others, was the big one. So the subset, okay, what you collect, the sample, is a subset of your population. All right, and then from that you get a description. Okay, what we was talking about just a moment ago. You'll mathematically analyze the data, see what inferences you can make with it, and then you'll get to your analysis. Okay, so basically that's a really good thought process for looking at your IA. Okay, let's see what we got here. So we have classifications of data. It could be numerical or descriptive. So numerical data, it's made up of observations that are quantitative and have a numerical value associated with them. So you could have heights, okay, something like that. Now categorical data, on the other hand, is made up of observations that are qualitative. So here's the big difference. Numerical is quantitative, while categorical is going to be qualitative, sometimes known as nominal data. Okay, almost a descriptor. So you could have car colors such as brown, blue, red, etc. Okay, so why don't we go ahead, jump down here. The first example, it says classify the data as numerical or categorical. Okay, is it something that can be assigned a specific numerical value, or is it more descriptive? Hello. Okay. Kiana? There you go, man. Mm-hmm. Okay, so what do you think about the breed of a dog? Is that going to be numerical or categorical? That's definitely categorical. Okay. The breed of a dog could be anything, but we're not going to assign a numerical value. It's possible to do that, but not the way we think about it. What about the winning margin in a football game? Okay, that would be what? Numerical, very good, okay, because it can be assigned a numerical value. What about the hair color of a person? Yeah, that's categorical. Okay. So this is just kind of designed to get you thinking about the types of data you could collect and what's going to be the most useful for you. Now, right below that, we have measurable or countable. Continuous data, data that is measurable. Heights, weights, ages, because you can have more than just say like whole number heights, right? Can you have a portion of a height? Yeah, that's really the difference between what we're calling continuous and discrete. If you can have a portion of this quantity, it's going to be continuous. If you can't divide it up, well, then it's going to be discrete. It has to be, your regular counting numbers. Now, we talked about this on Friday. We call them the natural numbers. What does IB call them? The cardinal numbers. There we go. Okay, call them cardinal. All right, so discrete is data that is countable, the number of IB students at whatever high school, the number of dogs in a kennel, etc. So let's take a look at this example right here. Classify the data as continuous or discrete. The number of dogs in a city. That would definitely be discrete. I mean, technically, I guess you can have a portion of a dog, but it'd be kind of gross. It would definitely be rough on that animal. Rough because it's yeah, okay. Kind of throw a little joke out there. Okay. There you go. Rained a lot this weekend. Hope he didn't step in a poodle. Okay, yeah. I'm going to keep going. The volume of water in a bathtub. That's definitely continuous, because let's say our unit of measurement is going to be, I don't know, say gallons. Can you have a portion of a gallon? Yeah, absolutely. Okay, so that is continuous. What about the time to walk 2 miles? That's continuous as well. Time is absolutely continuous. So just a couple of questions, when we're thinking about our internal assessment. Just to kind of think as you go along, how would you categorize the data you're collecting for your internal assessment? Okay, how is that data going to be useful to you? How can you help it to further your topic, your point? Numerical, categorical, continuous, or discrete? Okay. So now let's actually start getting into some of these methods here. So 30 children attended a library holiday program. Their year levels, I think that's supposed to be THEIR, but what are you going to do? Their year levels at school were, and then we have this set of data. Okay. So the tally is just a really fast, quick way to go ahead and get the number of elements you have in a set. But we're going to go ahead and create what's called a frequency table. It's the number of times that element occurs in a set of data. Okay, the frequency is just the number of times it appears or happens. Does that make sense? Okay, so let's go ahead and run through this real fast, starting with number 6. So we're looking at that set of data. How many times do you see 6? I see it 6 times. Now, I like to do my tallies in sets of 5. I think it's just a really easy, fast way to count them up. So we can go 1, 2, 3, 4, 5, and then 6. So the frequency is 6. So the tally and the frequency are basically the same ways of doing it. But instead of the tally marks, we're just representing it with the numerical value. We'll get to the relative frequency in just a second. Okay, how many times do you see a 7? Okay, I see 9 of those. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I'll tell you what, just go ahead and run down the list real fast. How many 8s do you see? 8. What about 9s? I heard 4. That is correct. 10. There's 2. And finally, how many 11s? There's only 1. Okay. Now, of course, the total is the total number of elements that I have in the set. So this is the number of times that each of the individual elements showed up. So let's see, 6 plus 9 plus 8 plus 4 plus 2 plus 1. 30. Okay, so I'm looking at 30 elements here. And if we go ahead and take a look, do I actually have 30? Yeah, there's 30 numbers up there, 30 numbers in our set. All right. Now it says here the relative frequency is found by dividing the frequency by the total. So think about this. You're dividing the individual value by the total. What does that sound like? Starts with a P. That's a percent. The relative frequency is a percentage. okay, of the number of times that particular element shows up in the set. All right, so we have 30. So for this first one, I'll go ahead and write it out. We'll have 6/30ths, which is one what? 1/5. So what are we looking at? 20%. Okay. 20%. Okay, good, 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 good. And let's just go ahead and keep going. The 7 shows up 9 times, so 9/30ths would be 3/10. Okay, 3/10, so 30%. Do you want me to go ahead and write out the fraction? Or are you guys okay? I mean, you guys are the ones running the show. Are you okay if I just put the percentage, or do we need to put where the percentage came from? What's that, sir? Just the percentage? Spencer, correct? Okay, so just the percent. So 30%. Okay, so 8/30ths would be what? 4/15ths. Now that one you may not know off the top of your head, so use your calculator to help you out. 4/15ths. This time I'll go ahead and write that. Anybody? Anybody? 4 divided by 15. Okay. 26%? Okay. So it was it 0.26 what? 6 repeated. So let's say 27%. Okay. So if we're just, yeah, let's just go ahead and say 27%. We'll round up. Okay. And let's go ahead and do the rest of these right here. 9, that would be 4/30ths. So what's 4/30ths as a simplified fraction? 2/15ths and 2/15ths. I'm getting 13%. Okay. 13%. And of course, you know, we're rounding these. 10 appears 2 times. So that would be 1/15. So we're looking at about 6.5%. Okay, I'll agree with that. And then our last one, 1/30ths. 3.25. Okay, so let's go ahead and say 3.2. Well, 3.3. Why not? Why not? 3.3%. Actually, well, no, 1/30th actually should just be 3%, right? Yeah. Isn't that right? What? Because multiplied by the 100. True. Okay. Okay. I'll take a look at that later. All right, so we filled in the table. Does anybody want me to finish filling in those tally marks? You guys okay with that? You do want me to? Oh, I thought you were saying this. Okay. All right. So construct a column or a bar graph to display the data. Okay, so there's going to be a big difference in the bar graph we create as opposed to what we're going to call a histogram in just a few moments. Let's do it on time. 144. Okay. So what should my horizontal axis be? Okay, the year. So we've got tick marks already created for me. So we've got your 6, 7, 8, 9, 10, 11. Okay, and how do you want to do this vertically? Like, what should we definitely go to? Okay. Well, we need to be able to go to what? What's the highest frequency? We have to be able to go to 9. Let's see if I have 9 tick marks. 1, 2, 3, 4, 5, 6, 7. We have 8. I could just add another tick mark, or we could just change the increment on the vertical axis. What do you guys like? Just add another tick mark? Okay. Mm-hmm. Yeah, then you make your, best estimation. Mm-hmm. Okay. And we're definitely doing this by hand. Technology is definitely going to be much more accurate than by hand. So let's see, 6 gave me 6. So I'm going to say 1, 2, 3, 4. Just number these like 1 to 9. Not all of them, but at least I have an idea of what the tick marks represent. So we're going to go up to 6. My bar is okay. Maybe a little bit high. There we go. Okay. And then we just want to go ahead and do that for the rest of each of these. 7 is going to go all the way up to 9. All right, then we got 8, which goes up to 8. Let me do this, kind of get an estimation of where that is. Okay. 9 goes all the way up to 4. So about right here. Okay. And then 10 goes up to 2. And then we've got 11 at 1. So something like that. There we go. So there's a bar graph to represent the frequency table. Remember, the frequency is just the number of times the element shows up in your set. Okay. Now, when making a column graph using discrete data, a space should be left between the bars, okay, because it's not continuous. Here we don't have a portion. We're just looking at the exact number of years. Okay. Now, if it was continuous, that's where you get a histogram, because you can get any portional value as we go through. But let's go ahead and answer some questions based on what we see here. What is the modal year level of the children? Okay, so what does modal mean?
The biggest occurs the most.
Okay, the element that occurs the most, the mode. So that would be what year? 7. Okay, because in the table we see that has the highest frequency, and in the graph it has the highest bar. Okay, so the 7th year. Okay. Describe the shape of the distribution. Are there any outliers? Okay. Well, what we're talking about is, and this one is always kind of getting a little bit ahead of itself, but when I say bell curve, do you guys know kind of what it is I'm referring to? Okay. Have you ever seen a graph that looks like that? Okay, it looks almost like a bell, so we refer to it as a bell curve. That's when we say data is normally distributed. Okay, so if I were to look at this, if I were to go ahead and put a smooth curve connecting the top of the bars all the way across, well, you'll notice it's not exactly symmetrical. Okay, the way it is here, we're going to go ahead and say that it's positive or right skewed. Okay, because if it's the majority of it, if it's on the left, then that's a positive or a right skew. Okay, well, what would happen if the majority was on the right side? That'd be a negative or a left skew. Okay, so this is a positive left skew. Yep, if I could spell today, that'd be great. Did I say right? We just answered, yep. And so, you know, what happens is if you ever see something like that, it looks like I made a mistake. It's actually just a clever teaching tool because I try to keep you on your toes. Just trying to see if you're paying attention.
So when you're saying
Yes. Lord.
that it's like a right skew, does that mean that like the right side of the graph is what's correct?
What's lower?
What's low?
Yeah, because right now we don't have any symmetry to the graph.
Okay.
Okay. Yes.
Then a negative would just be flat.
Yes. It would just be more bulged on the right side. And normal distribution, what we're going to find out when we start getting here and we start talking about standard deviation, the mean, median, and mode are all equal if it's normally distributed. And the thing about data, I mean, if you collect data and it's not normally distributed, we can make it normally distributed. There are ways to manipulate in here. Now, we're not going to worry about that in here. I just thought maybe that would be something you'd find interesting. Okay, but let's see. Next question. What percentage of the children were in year 8 or below? Okay, so you could look at this, the bar graph, or just the table. So year 8 or below. Okay. 77%, because how many children are we talking about? 8 plus 9 plus 6.
So 23.
23. So is everybody okay where we got to 23 kids? Okay. Because we're looking at year 8 or less. So whether it's from the table or the bar graphs, we have 23 out of the total 30. And yeah, I got 76.7, but I'll go ahead and say just 77%. There you go. These are frequency tables. Okay. Very, very easy way just to categorize your data. Okay. Bar graph, very easy way to visualize it. What percentage of children were above year 9? So above year 9 now, does that include year 9? No. So we're only talking about how many kids? 3. Okay. And that would be, yeah. Okay. So what's my percentage here? 3/30, which is 1/10. And that's what? About 10%. Okay, yeah. All right. What do you guys think? Any trouble so far? Caitlin, what do you think?
Great.
It's great? Okay. All right. Let's take a look at what else we got. All right. So now we're going to go ahead and move on. What if your data is going to be classified by interval classes? Okay, now this is a kind of an unusual example because I can see what the data is, but if your data is going to be broken into these class intervals, you won't always know exactly what they are. Okay, so here we're going to be able to see kind of both sides of the fence. It says the following figures are scores on a 175-point assignment of a group of students. Okay, so you've got all these scores here. Group the data into classes as shown, tally the number in each class, and write the frequency. Okay, so basically what we were doing just a second ago. So let's go ahead and do this, and then I'll go back and put the tally marks in. Okay, or do you want to take like 2 minutes, see how far you can get? Okay, let's see if you can figure out how many times the elements, the frequency, is appearing in this set. Okay, so let's see if we all get on the same page. How many of these scores, okay, that have a maximum 175 appear between 148 and 150? You know, and this is definitely a time where as you use a score, mark it off so you can definitely tell you used it. But does anybody have an idea how many elements will be in that class interval? It is 3. Very good. There are 3 scores. Okay, so let me go ahead and give you 2 minutes, and let's see how far we can get with the frequency table. One minute. Time flies when you're having fun. Okay, that's been 2 minutes, and you may not have finished the table, and that's fine. But let's go ahead and see what you have so far. How many elements are going to be in the class from 151 to 153? Okay, I heard 8, I heard 9. I got 8. There are 8 values in that class. 2, 3, 4, 5, 6, 7, 8. What about 154, 156? I got 7. Okay, lucky number 7. So we're close. It's easy to miss, especially the more data you have. There's more potential for those little mistakes. Okay, so that's okay. 1, 2, 3, 4, 5, 6, 7. 157 and 159. 4. Okay, there are 4. We seem to agree on that one. 160 to 62. 6. Very good. Okay, 1, 2, 3, 4, 5, 6. 63 to 65. There's only 2. Very good. 2 tally marks. 66 to 168. There's only 1. Okay, so 1 tick mark, tally mark. 169, 171. There are 2, and then what about the last one? 3. So 2 tally, 3 tally marks. Okay, good. Good, good. So is everybody understanding the frequency, what that idea means? Okay, the number of times that an element occurs in a set of data. Okay, well now let's go ahead and take a look at the relative frequency. Oh, and what's my total? How many of those do I have? There are 36, yes. Okay, so in order to find the relative frequency, which we before mentioned is a percentage, I'm going to take the frequency, the number of times the values appeared in this interval, and divide by the total. So for example, 336, what's that simplified ratio? 1/12. Would everybody agree? So what are we looking at as a percent? Well, actually, you know what? Do we need to, everybody's okay with changing them to percents, right? Do we need to go ahead and list those? Do you just want to go ahead and list the simplified fractions? Okay, let's just go ahead and do that. That'll make it a little faster. So let's see, 8/36. What would that be? What divides both 8 and 36? 2 ninths. 2 ninths. And then we have 7/36, but 7 is prime number. Okay. Let's just see, what do you call a number if it's not prime? If it has multiple factors? Optimus. Autobots, roll out. Okay. No, but a very cool pop culture reference. Starts with a C. Composite, who said it? Very good, yes, composite. Okay. 4/36. 1/9. 6/36. 1/6. 2/36. 1/18. Okay, 1/36 will not change. 2/36 again is another 1/18. And then 3/36, as we got before, was 1/12. And it's super simple to get that percentage. Just divide it out and multiply the decimal by 100. 10, close. Okay. All right. So any questions on how to fill out the frequency table or to get the relative frequency? Okay. 158, so we're still doing good on time. Okay, so let's take this information and let's represent it visibly, or visually, I should say. Now, make a column bar graph to display the classes of heights. Now, here's where the difference comes in. Would you classify this as discrete or continuous? This one is continuous. Now, we're not taking a portion of a value, like for example, we don't have 156.3, but we have all of these different values, all of these different whole numbers here. Okay, and you'll notice the way that the intervals are set up, we go to 150 to end the first interval, but then the next one starts right up at the next consecutive number. Okay, 151. So if it's discrete, we want to go ahead and use a bar graph as we used just a second ago. So there's going to be a space between them. But if it's continuous, there's not going to be any spaces between the bars. In fact, does anybody know what we call a bar graph that we've squeezed together? It starts with an H. We call it a histogram. Yes, very good. We call that a histogram. Okay, so we have this right here, and I'm not going to remember this, but the first class, it went from 148 to what? 150. The second class started at 150, so I would have each of the bars starting on its lower value, the way we've set up this horizontal axis. Now, what are we going to do for the vertical? We have to be able to get up to, what was the highest frequency? 8, and let's see if we're okay with this. 1, 2, 3, 4, 5, 6, 7, 8. We're perfect. Okay, 1, 2, 3, 4, 5, just to kind of give an idea. All right, so we had how many elements in the interval 148 to 150? 3. So this first interval right here, I'm going to go up to 3, and then I'm going to come straight down. Okay, because 151 starts the next interval class. Does that make sense? This is the difference between a bar graph and what we're now calling a histogram. There's no spaces between them. Okay, so this one went up to 8. So the third class starts at 154, and it had how many elements? 7. So I'm going to take this guy up here. This board is squeaking loud. Okay. Next up, 157 to 160. Or 159, I should say. 4. So this one's only going to go up to 4, so that's right about there. Okay. But is everybody okay? Every numerical value that you could achieve on this test is going to show in one of these bars right here, one of those class intervals we've used. The next one starts 160, where we have how many elements? 6. I'm going to go up to 6. And then the next one, what do we have? 2, 1, 2, 3. So 2 elements in that interval. 1. Someone just not. So, and I'll go ahead. Whoop, I think I got a little ahead of myself. Yeah, that's it. Okay. Hello.
I'm leaving early. There's another copy of what we did yesterday.
The prerequisite?
Yes, 5 questions.
The 4 questions? I don't have any more copies. I've already given out my last one, but it is on the website.
The website.
You can print one out?
Like Google Classroom.
Yes.
Okay.
Okay. And this desk that you sat in, is this yours?
Yeah, that's fine.
Okay, there you go. No problem. Have a good day. Okay, and this one here, oh, I guess it just got cut off. That's where the 174 should be, and then that had 3 elements in it. So I'm just going to go up to 3. So there we go. There's our histogram. But again, it still represents frequency, the number of times an element shows up in a set. Okay, how we doing? Anybody having issues? Yeah, mine aren't perfect either. I mean, you know, I've, with practice, graphs and things like that get better. I know it sounds a little sketchy, but it's a drawing, get it? Yeah. Okay. That joke was super funny, bar none. Okay. Yes, ma'am.
Okay, so with this, you still classify Instagram as the same way as like our graphs with the positive skew and the right skew?
Yeah, you could. So in this case here, I would be probably inclined to go ahead and classify it the same way, that it had the positive or right skew, because it's got that same general shape. It's definitely not symmetrical about the middle. Okay, so it's not the normal distribution as we call it. And actually, we're going to get into that probably in the next week or so it's not going to be very long. Okay. Good, good, good. And I think all we have left on this lesson, we're going to go ahead and do another example, and then I'm going to go ahead and talk to you about some box and whisker plots. But I've got 204. Why don't we go ahead and stop there for today? Normally I wouldn't stop, this early. I'd go up to at least like 7 or 8. But we do have to do what? They want us to cover the expectations, and I know you guys were expecting to do that. So.